What if you could make your AI model generate text 2 to 3 times faster, without changing the model, without losing any quality, and without buying better hardware? That's speculative decoding. Welcome to Tech Decoded by Amtalk Soft. I'm Alex. Today we're diving into speculative decoding, one of the most underrated optimization techniques in AI. By the end of this video, you'll understand exactly how it works and why it's becoming table stakes for any serious AI deployment. Here's the fundamental speed problem with language models. They generate text one token at a time. Each token requires a full forward pass through the entire model. For a 70 billion parameter model, that's 70 billion multiply and add operations per token. At 30 tokens per second, a 500-word response takes about 50 seconds. And here's the frustrating part. The GPU sits idle for much of this time, waiting for data to load from memory. The bottleneck isn't compute, it's memory bandwidth. The key insight behind speculative decoding is simple but brilliant. Most tokens are predictable. When the model generates the capital of France, the next token is almost certainly Paris. You don't need a 70 billion parameter model to predict that. A tiny 1 billion parameter model could get it right. So why waste the big model's time on easy predictions? Here's how speculative decoding works in 4 steps. Step 1, draft phase. A small, fast draft model generates several tokens ahead. Let's say 5 tokens. This takes milliseconds because the draft model is tiny. Step 2, verification phase. The large model processes all 5 draft tokens in a single forward pass, not one by one, but all at once in parallel. It checks each token against what it would have generated. Step 3, accept or reject. If the large model agrees with a draft token, accept it. That's a free speedup. If it disagrees, reject that token and everything after it, and use the large model's answer instead. Step 4, repeat from wherever the last acceptance ended. The magic is in the verification step. Normally, the large model generates tokens one by one, but checking whether a sequence is correct can be done in parallel. All 5 tokens verified in a single pass. If the draft model has an 80% acceptance rate, you get about 2 tokens accepted for every verification pass. That's roughly a 2x speedup. For code, where syntax is rigid and predictable, acceptance rates hit 85 to 90%, giving you 5 to 3x speedups. And here's the critical point that makes speculative decoding special. The output is mathematically identical to running the large model alone. This is not an approximation. It's not trading quality for speed. The verification step guarantees that every accepted token matches exactly what the large model would have produced. You get free speed with 0 quality loss. That's rare in optimization. Let me give you the real-world numbers. For code completion, using a 1 billion draft model with a 70 billion target, you get 5 to 3x speedup. General chat gets 8 to 2x. Technical documentation gets 2 to 8x. Creative writing is the lowest at 5 to 8x because creative text is inherently less predictable. The more structured and predictable the output, the bigger the win. Now, in 2026, speculative decoding has gotten even better. Eagle 3 achieves 3 to 5x speedup over standard generation. That's a 20 to 40% improvement over Eagle 2. It fuses information from multiple model layers, not just the top layer, and uses training time testing to better simulate inference conditions. And there's speculative decoding, published at Eichler 2026, which applies the speculative principle recursively, achieving up to 5x over standard generation. The coolest development is self-speculative decoding. This skips the draft model entirely. Instead, it uses the early layers of the large model itself as the draft. Layers 1 through 8 of an 80-layer model make a quick prediction, then the full 80 layers verify. Same principle, no extra model needed. This is now built into vLLM and SGLang out of the box. Implementation is straightforward. In vLLM, you just add a speculative model parameter when creating your LLM instance. In Llama CPP, you pass a draft model flag on the command line. The frameworks handle all the orchestration for you. You can literally add speculative decoding to an existing deployment in 5 minutes. When should you use speculative decoding? It's great for interactive applications like chatbots and coding assistants where latency matters. It's ideal for predictable output domains like code and structured data. But it's not the best fit for high-throughput batch processing, where batching already saturates the GPU, or for very short outputs where the overhead isn't worth it. Speculative decoding is part of a bigger trend, making inference smarter instead of just making models bigger. Combined with quantization, continuous batching, flash attention, and KV cache optimization, these techniques can make a single GPU serve 10x more users than naive inference. The models aren't getting smaller. We're just getting dramatically better at running them. If this was useful, subscribe and hit the bell. We break down complex AI topics into practical knowledge every week. Links to the full written guide are in the description. Next up, Edge AI, running language models on phones, EOT devices, and anywhere without an internet connection. See you there.